Hi everybody, we're team number 5. This is our robot designing class. This is our second project. Our team is composed by Diego Bolivar, Siavash Rastkar, and myself, Diego Quintero. So what are Bobots? Bobots are actually a robotic platform sold by Parallax company. How do they work? Like I said before, there are robotic platform. The hardware is already done. We only need to program the code and actually just put it in the robot. Which software was used to program it? We use PBasic as our program of choice. Objectives for this project, we actually did 3 tasks, and we're going to explain them in detail in a while.
For our task 1, we were asked to do a dance movement using our robots. The objective was just to develop a 1-minute routine to display the synchronized movement of 2 robotic platforms. Some of the problems that we actually have with the robots was they were all kind of different even though they were the same. They have, if you have different batteries, or the batteries were different charge, they will move totally different. If some of the parameters on the movement on each of the sensors and everything else will change everything. So we have to manually fine-tune both robots to make sure they actually do the motion exactly the same. These were the dance movement were created by subroutines of the program. Each subroutine will create the movements, and then with those movements we'll put it together with music, making it look like it was a dance. Next, we're gonna see the video. It's gonna show us how these movements were synchronized with the music. Next, we're going to show you task 2.
Our task 2 was to do a workspace scan. Our objective in this task was to do a complete scan of our whole workspace and find the furthest object and move toward it. Our problems in this task was to distinguish the walls of the wall from our workspace objects, and also deal with the errors of the sensors in reading the distances from 2 objects which are close to each other. So for solving this task, we did this. We put the robot in the middle of the workspace and wrote a code to make the robot to do small steps, and at each step measure the distance of the object from it and compare it with the previous distances. So this way, by making a whole circle, it can find the furthest object, and finally it can align itself to the target and move toward it. In the next slide, we are going to see the video of the robot in action. As you can see here, the robot is placed in the middle of the workspace, and it's doing small step turns, and at each step it's measuring the distance of the front object, and after making a complete circle, it's going to move toward the furthest object and stop at the 2-inch distance of the furthest object. In the next slide, we are going to present our task number 3.
Okay, so for task number 3, we actually developed a path in which our robot will go through it. It's gonna start on the first box. It's gonna do some obstacle avoidance, as you can see here. Over here, it will do a parallel parking, and then it will do a backward parking. So our objective for this task was to actually develop a robotic task for the Bolivar platform that requires the use of all the available sensors on board. Also, we need to develop a necessary workspace to demonstrate the performance effectively. Some of the problems presented was actually the robot wasn't turning exactly 90 degrees. So we actually had to manually fine-tune the robot to do the 90-degree turn. Also, if we had too much space between the objects, our error for the 90-degree turn, it will increase. So we actually had to shorten the track, and that way we minimize the error. Also, we wanted to do the whole path in a smooth motion. So we actually had to, again, to manually fine-tune the robot in order to do this. The solution is going to be presented on the video, and we'll be discussing that. Okay, so at the beginning, the robot will move towards their first objective. It's going to read the distance, and then it's going to do a right turn. After doing that, it's going to approach the second obstacle. It's going to read the distance and turn left. Then here it's going to do an obstacle avoidance. It's going to go and read the distance, and we actually do a specified distance in order to avoid the box that we wanted to do. Here you will do a measurement and turn left. Again, that distance was designed by us. Here is going to do the parallel parking. After it reaches a certain distance from that object, it will do a backwards motion. It's going to do a right 45-degree turn and a left 45-degree turn. Then it's going to read the distance again from the front object, and it's going to do a backwards motion until it reaches to the second object. Here, to finalize the motion, it's going to do a turn, and that's pretty much our task number 3. So to summarize our project, we actually 3 specific tasks were successfully programmed and tested on several robotic platforms. Also, a survey overviewing the scopes of the robots, an example of its application, were explained and presented thoroughly. As well as the problem presented throughout the programming and the testing phases were satisfactorily debugged and corrected. Thank you.